Hello students, Jai Hind to all. So today we are going to start a new chapter, chapter 4, Introduction to Problem Solving. So dear students, first of all we will try to understand that what is the problem. Okay, so our discussion will revolve around this, what is problem. So students, problems are at the center of what many people do at work every day. A matter or situation regarded as unwelcome, harmful and needed to be dealt with overcome is known as problem. So problem can be a matter also, problem can be a situation also, and which situation and which matter which you unwelcome, which is harmful and you need to deal with overcome. You want to overcome with that problem, you want to come out of that situations, and such type of the situation is known as problems. So everyone's having some problems in their academics also, problem in their life also, or maybe problem in their at their homes also. So students, this computer or microprocessor is the main device nowadays for finding the solution of a problem because of its speed, because computer has a very fast processing speed and the way it can deal with the data. So generally students, problems are solved using some sort of program or software. We use the programming language. So as we are studying, the Python is one of the programming language through which we solve different type of the problems. Now see, what are the problem solving cycle? So there are three basic steps students for solving any problem using computer or computer program. First, we define the problem. That is called do the analysis of the problem. So define your problem well. Try to understand your problem well. Second thing, design solution, develop the algorithm that how to find the solution, how to overcome that problem. So develop an algorithm, do the coding, then testing, then debugging, find the errors. When you get the correct output, then it will be a solution for your problem. Now implement the solutions, means develop the applications with the help, write the code and give to the customer what that app, that application, what the solution you have made. So this is a problem solving cycle. So first we define the problem, analyze the problem, then we design the solution, then we implement the solutions, and so on. So what is the problem solving cycle? So first step of the problem solving cycle, students, is the analyze or define the problem. Every problem solving methodology, the first step is defining or identifying the problem. Students, it is the most difficult and the most important of all the steps. It involves diagnosing the situation so that the focus on the real problem and not on its symptoms. So here that we diagnose the situations, that focus on the why this problem occurs. For example, if performance in any department is substandard, we might think the problem is with the individual submitting work. However, if we look a bit deeper, so what we find, the real issue might be a lack of training. Why they are not performing the department? The personnel of the departments are under trained, they lack the training, or maybe some workload to them. As above example, same thing may happen with the problem solving using computer programs. So before we start designing or coding, problem must be thoroughly defined, thoroughly analyzed. What is the cause of the problems? What are the factors of the problem? So in the problem solving cycle, students, we define the problems. So the process of understanding the problem and then defining it on the basis of following means data requirement of what are the data required for the given problem, type of input variable required, type of output variable required is called the problem definition. Now suppose we are assigned to solve an arithmetic problem and we are not familiar with the steps involved in solving that problem. In such case, students will not be able to solve that problem. If you don't know how to find the HCF and LCM someone has given the problem, you'll be able to solve it? No. The same applied to writing computer programs. A computer programmer cannot write the instructions to be followed by the computer unless he knows how to solve that problems, unless he don't know what is the algorithm to be used for that problem. The first step in application development is the problem definition. In addition, a program, source data, logical and practical procedures, needed to solve the problem. Students, this analysis must take in place before actual preparation of program development, otherwise it will cause much cost and time. Now solving cycle. Design solution. Design is the process to transform the user requirements into some suitable form, which helps the programmer in software, coding and implementation. So students, the program design tools are the tools used to develop a program, and the following are some of them. What are the programming tools we use? Algorithm, flowchart, pseudocode. In this chapter, we will study in detail about the flowchart and the pseudocode. So, design solution. How to design the algorithm? Students, algorithm basically is a plan, and this is a plan which is followed a step by step in a sequence manner. So, algorithm is a plan, a logical step-by-step process for solving a problem. Algorithms are normally written as a flowchart or in a pseudocode as it is next level. When designing an algorithm, there are two main areas to look at: the big picture, what is the final goal, the individual stages, what hurdles need to be overcome on the way to the goal. Students, in the problem solving cycle in the design solution, here we see how we write the algorithm. So algorithm to find the largest of two numbers. Suppose we have two numbers and we have to find which is the biggest one. So first we declare the variables a and b which are going to store these two numbers. Now we read the variables a and b, what the value they store. If the value stored in variable a is greater than b, then we display a is the largest number. If the value present in a is greater than b, we display a is the largest number, else b is the largest number. Now flowchart, student. So flowchart is the graphical representation of steps. So this is start of the program, processing steps, comparing, conditional step, all these we represent with the help of the symbols. So flowchart is a simply graphical representation of steps. It shows steps in a sequential order and is widely used in presenting the flow of algorithm. So algorithm is converted into flowchart, that is called the workflow or process. Flowchart shows the steps as boxes of various kinds and their order by connecting them with arrows. Here we see we use the flowchart symbols. This oval used as a terminator or start. Different flowcharts shapes have different conventional meanings. The meaning of some of the common shapes are given here. This is used to terminate the program or start the program. Process is represented by rectangle. A box indicates some particular operation. Whatever the operational processing steps you are doing in your program, calculation, addition, subtraction, multiplication, division, and this is a document, represents a printout such as a document or a report. In the rhombus, we represent the decision conditions we write here. That if A is greater than B, so this condition will be written inside the decision box, that is the rhombus. So diamond represents a decision box or branching point. Lines coming out from the diamond indicates different possible situations. Decision taken here in the if condition which will be used in the diamond, there will be two output, either true or false. So here's from here in the diamond, two branches will take out, one for the true and one for the false. Now data means here input output is represented inside the parallelogram. So it represents the information entering or leaving the system, and input might be in an order from a customer and output can be a product to be delivered. So input is what the customer has placed the order, and output is the product which is delivered to the customer. Flow, this line represents the flow of the sequence and the direction of a process. So now see, this is the representation of the algorithm using flowchart. So here the flowchart of addition of two numbers. See, with the help of the oval symbol, students, the program we represent the program is going to start from this step. Then we read the number A. This is the input in parallelogram. Then we read the number B, second input, second number. Then we do the processing here in the rectangle. We add these two numbers A and B and assign to the some variable. This is the processing step. Now we print its result in the output, that is in the parallelogram, and again the program is going to terminate. This is the end. So this entire thing is called, students, a flowchart. Here the program start and here program ends. Similarly, here it is another representation of the flow chart of finding the largest of two numbers. The program starts from here, students. We accept, take two inputs A and B. Now here you see this is the decision. If A is greater than B, so true leg is, so the control will go through the true legs. So this branch will be executed. If the condition is false, then this branch will be executed. So if A is greater than B, so this true leg will be executed, means display A. We saw on the screen output, A is the greatest, display A. And after that, the program is going to terminate, stop here. Now if A greater than B is false, then false leg will execute and display B. B means B is greater. And again the program is going to be terminated. In this way the students flow chart work. Now we have discussed what pseudocode. So writing the algorithm code into a, not a programming language, into your own language, local language, in the English language, simple way. This where we don't have to follow any syntax. A set of instructions that does not have to use specific syntax. There is no strict set of standard notation for the pseudocodes, but some of the most widely recognized are: we use the input statement for taking the input. Read indicates the user will be inputting something. Output and write we use, which indicates that an output will appear on the screen. While a loop iteration that has a condition at the beginning. For we use as a counting loop. Repeat until a loop. If then else. A decision selection in which a choice is made. Any instructions that occur inside a selection or iteration are usually indented. Now students, see representation of the algorithm using pseudocode. So here write, please enter two numbers. Read n1 and n2 means read two numbers. If n1 greater than n2, set max to n1. So that means n1 is the maximum number. Else set max to n2. So this is the pseudocode, simple pseudocode in the English written. It has no such proper syntax there. Okay. So this is all for today, students. Thank you for your attention and cooperation. Jai Hind.